Here's another example involving a quadratic equation. This one involves an area again. A vacant rectangular lot, says rectangular, so I'm immediately going to draw myself a rectangle, is being turned into a community garden measuring 15 meters by 12 meters. So this is the shorter side, so I'll say 12 there and 15 meters here. A path of uniform width is surrounding the garden. So if I can try to make that a little bit uniform, it's okay if it's not perfect. I'm really not an artist. So we have a uniform path surrounding the garden. The area of the entire lot is 378 square meters. Just taking a little moment here, 15 times 12 is actually, I think, 180 square meters. So the remainder of that is going to be made up of the path. What we want to do, according to this problem, is find the width of the path that surrounds the garden. So since we don't know the width, but we know it's a uniform width around, let's let x, the thing we don't know, be the variable in this problem. So x is the width of the path. Let's go ahead and throw that in here. So x is going to be the width here, like walking across there. It's going to be the width here. It's also the width here and here. So you can imagine you've got x going across and up and down on either side of the path. So when we examine this entire lot, if we were to start at this corner and walk across to this corner, we would first cross the path. So especially if we were doing it from the middle, we'd cross the path, then we'd go 12 meters, and then we'd cross the path again. So this is x, the path, plus 12 plus x. This width actually is 2x plus 12 as an expression, because we cross the path twice as we go across that lot. If we go across the lot the other direction, so up and down, I would go across the path, then I would go 15 meters the long way, and then across the path again. So I would have an x, a 15-meter walk, and then the path again. So the length of this would be 2x plus 15. So I have a length of the entire lot that is 2x plus 15, a width of the entire lot that is 2x plus 12. Now, remember, in a rectangle, the area of any rectangle is length times width. So what we have here is we're given that the area is 378 square meters, and the length and width we figured out from this picture to be 2x plus 15, and the width is 2x plus 12. So here we have a product equal to 378. We have an equation for the scenario. Now, because this is a product, it would be useful if it was equal to 0, but it's not equal to 0, so it's useless. So we need to multiply that out and get 0 on one side before we do anything else. So 2x times 2x is 2x squared. Outside terms would give me 24x. Inside terms would give me 30x. And then finally, with our FOIL, 15 times 12 would give me 180. Now I want 0 on one side, so I'm going to move that 378 to the other side. I have 4x squared plus, collecting like terms, 54x. And then when I subtract 378 from 180, again, feel free to use your calculator. This is an application. We get negative 198. I used my calculator. All right, so next we want to factor this trinomial now that we have 0 on one side. If you have something common, take it out. I can see at least a 2 because these are all even. If we could take a 4 out, that would be even better, but unfortunately I think the most we can do is take a 2 out. So when we take a 2 out, we get 2x squared plus 27x minus 99, I think. Yep, that's what my calculator says. And next, we want to factor the trinomial that's left on the inside. So 2 times, we're going to have two binomials here. 2x times x is the only way to factor 2x squared. You could go ahead and use the AC method, showing the box or showing the fractions, and throw your answers back in here. I'm just going to go ahead and use trial and error. That's what I kind of grew up with, and I still tend to use it when I'm working through problems, but you don't have to. You can use one of those alternative methods. I'm going to write out the factorizations of negative 99, 199, negative 3, 33. Now, pause there. Remember, I'm looking for 27. 33 is darn close to 27. That 2, if I multiply by the 3, is going to give me 6. 33 minus 6, there's the 27. So with practice, trial and error, like I said, I've been doing it for years. It ends up coming out pretty well. I want the 3 to multiply the 2, so I'll put the 3 there and the 33 here. If you use the AC method, the box will immediately show you that the 2x and the 33 need to be together. And or the fractions will show you that as well. Here's the factorization. Always do a double check before continuing. Now we have a factorization where we have 3 factors. 2 can't be 0, so we set the other 2 instead that involve x equal to 0. So we have 2x plus 33 equals 0. To solve, subtract the 33, divide out the 2, so we get negative 33 halves. And then the other one, x minus 3 equals 0, add the 3 to both sides, we get x equals 3. Now remember what x is. It was the width of the path. We cannot have a negative width. That's extraneous. So even though it works in the algebra, it does not work in the scenario. So the width of my path is actually 3. Now 3 what? Our area was in square meters, so this is going to be 3 meters. So the path, or the path's width, is 3 meters. One last thing, you should always check as you work through these problems. If I do a little picture again, remember what we figured out is that we have a width of 3, and it goes 15 across, and then 3 plus 15 plus 3 means the entire length here of this garden would be 21. The other direction, we'd have a 3 and then a 12 and then a 3, so that would be 18 going this direction. If we do 21 times 18 in our calculators, 21 meters times 18 meters gives us a correct area of 378 square meters. So a little quick check to make sure that everything works out with a little new diagram since my first one was so messy.